Today we're going to spend some time discussing the mathematical topic of geometry, and we're going to learn about a specific family of geometric figures. As I begin though, let me point out that when we're talking in mathematical terms, we have to be very precise. You might say, Jim, let's see you draw a square on the board, and I could come up and draw a shape like that, and in some situations that might suffice as a square. But of course, in the realm of mathematics and geometry, that is not a square. The lines aren't straight, they don't all connect, they're not the same length. So as you can understand, if we're in a math class teaching geometry, that's not a true square. We're going to be learning some specific things about some shapes today that help you understand how to define them and to distinguish between them. A few things about all quadrilaterals, which is what we'll be discussing today. And the word quadrilateral gives you an idea of something about it already. Quad meaning four, lateral meaning side. We're going to talk about four-sided objects. That's what quadrilaterals are. Now, there's some features about them, though, that have to be included. One is that they have to have four straight line segments forming their sides. They have to be two-dimensional objects. Three-dimensional objects are not quadrilaterals. And the line segments must connect at the ends to form the corners of the quadrilateral. So let's get started. Here is a sample of a quadrilateral. It has four line segments forming its sides. They all connect at the ends. And so this is a reasonable quadrilateral. There's not much else that we can say about it specifically, since it's not a particularly specific shape. But if we wanted to, we could adjust it just right so that this top side and this bottom side are parallel. If we do that, it now becomes the first classification of more special geometric figure, which we call a trapezoid. A trapezoid is simply a quadrilateral, meaning it has four sides, and two of the opposite sides are parallel. So the first of our more specialized shapes is the trapezoid. Now, moving on to other types of quadrilaterals, we could have a quadrilateral of this shape. It also has the requisite four sides, and you can see that the top and the bottom are parallel, as they were in the trapezoid. However, the other two sides of this figure are also parallel. It has two pair of parallel sides. We call this a parallelogram. It can be taller or shorter as you wish, as long as both pair of opposite sides are parallel. It qualifies as a parallelogram. Here we go. All right. Beyond simply a parallelogram, we can adjust this figure a little bit more so that not only do the lines on the side stay parallel, each of the corners now is a perfect 90-degree angle. That causes it to now be classifiable as a rectangle. A rectangle is most simply defined as a four-sided or quadrilateral shape with all corners of 90-degree angles. It's now a rectangle, a little bit more specialized quadrilateral. Now, we can continue getting more and more specialized. This quadrilateral is a little different. As we can see, it has no parallel sides, although it is a quadrilateral. And the interesting thing about this one is it's defined by having two adjacent sides of the same length and two other adjacent sides of the same length. This is called a kite, by no surprise, and any quadrilateral who has two adjacent sides of the same length and the other two sides of adjacent length is referred to as a kite. As with the other shapes, it can have a little bit of variation in exactly how it looks. But if those sides are the same length and these sides are the same length, it classifies as a kite. Moving on, we have a little bit larger piece here that has a little bit more specialized features. Now, each of these that we have looked at can also be a part of the earlier classifications. As we can see here, the kite had two pair of adjoining sides that were the same length. This shape has that. This shape can be turned so that it has four 90-degree angles, which would make it a rectangle, which it is. It also has two sets of parallel opposite sides, which makes it a parallelogram. And since it also has at least one set of parallel lines as sides, it's also a trapezoid. But in mathematics, we always want to use the most specific term that we can when we're referring to an object. So always use the most specific one into which a shape will rightfully be classified. We could call, the name of this in its current form here is most commonly a rhombus. And a rhombus is defined as a quadrilateral with four sides of equal length. Each of the sides is the same length, and so it will always have a shape roughly similar to this one. That forms our rhombus. Now, we have one other specialized quadrilateral that is very common to all of us. If I take this rhombus and turn it so that all of its corners are also 90 degrees, we obviously recognize it as a square. As all of our previous objects could classify in multiple of these families, the square qualifies for all of them. Although, since it is a square, we want to refer to it that way so we won't confuse it with any of the other quadrilaterals. The square has equal length sides, four corners, 90 degrees, and probably the most common of the quadrilaterals that we deal with all the time in structures and buildings and so forth. Now, we've talked about a variety of quadrilaterals. All of the quadrilaterals that we've talked about at this point we can consider to be simple quadrilaterals, and the square being the last one that we discussed. We can have quadrilaterals, though, of a little different nature. If, for instance, I had a four-sided shape like this, this is also a quadrilateral. But since it has what I would call an inside corner rather than an outside corner, this is more accurately referred to in the class of complex quadrilaterals because its features put it in a little different category. Another type of complex quadrilateral might look something like this, which has even more complex characteristics than the other ones that we have looked at. So, to complete our family of quadrilaterals, let's include those we can refer to as complex and have now a fairly complete family picture of the family of quadrilaterals in the study of mathematics and geometry. Thank you for watching.